S-CP.A.1, worksheet number 2, all about what we call the fundamental accounting principle. If you get the name like fundamental, you must be pretty fundamental. And that usually means it's quite a straightforward and also a very important idea. The fundamental accounting principle helps us generate the size of a sample space quite easily. So for instance, if you go to Subway, and they say to you there are 4 types of breads and there are 10 types of meats and there are 3 types of cheese and so on, and they could want to advertise to you all of the combinations. Now this isn't they've got more than this, I guess is what I'm saying, but we're simplifying it. So you might say, okay, how many different ways could I arrange the sandwich if I get to pick 1 bread, 1 meat, and 1 cheese? Well, the fundamental accounting principle states this very simple thing. You'd just take the 5 bread, you'd multiply it by the 10 meat, and then you'd multiply that by the cheese. And then they would say, there's 150 different ways. Now let me give you just a little sense, another picture sense of the fundamental accounting principle. That was kind of going on a minute ago when I was shooting the previous video about sample spaces, the idea of a tree. So in other words, if you have 5 different bread 1, bread 2, bread 3, bread 4, bread 5, so that's kind of like your first layer. There were 5 in that first layer. Now, for every bread that you could choose, there would be 10 different meats that you could choose. Now, I'm not going to do the whole thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is meat 1, meat 2, meat 3, meat 4, meat 5, meat 6, meat 7, meat 8, 9, and 10. Now, imagine that an array of floral there, whatever we got on each of those. So that would be, we would have to be at 50 now, 5 times 10, to see the easiness of the multiplying. And then basically from every one of those, all 50 of those, you'd say, all right, cheese 1, cheese 2, cheese 3. So you would have 5 times 10 times 3 is that magic 150. So the fundamental accounting principle basically says just to multiply through each of the options. Now, and basically its formal statement is this: if there are X ways for the first event and Y ways for the second event, then the sample space size is just X times Y. Now the last thing I'll say to you, and it's the ones that are often done incorrectly, is they'll say, how many lock combinations? Here's a 0 through 9, 0 through 9, 0 through 9, 0 through 9. Here's a combination on a lock, 5, 3, 1, 8. And the question becomes, how many different lock combinations are there if there are 4 spots, and in those 4 spots you can have a 0 through a 9. Now don't be tricked, a 0 through 9 is 10 different numbers. So there's 10 different things that could be in here, and there are 10 different things here, and 10 different ones here, and 10 different ones here. And so it isn't 40, okay? 40. It's 10 times 10, 100, times 10, 1,000, times 10. It is 10 to the 4th, or 10,000 different combinations here, not 40. Be careful of that. Sometimes the fundamental accounting principle gets tricky when you do that. Think of the same thing about flipping a coin 3 times. Heads or tails, heads or tails, heads or tails. Okay, that isn't 6. It's 2 to the 3rd, which is 8. You flip a coin 3 times, there are 8 things that could happen. And I could list them to you, but I don't want to, but it would be head, 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 tail, 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 head, tail, 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 head, tail, and so on. It gets hard to list them. That's why maybe a tree diagram would help me organize it.